So in this video, we'll be covering improper integrals. Now, first question that comes to mind is what is improper integrals? So let's go over what is integration first of all, and how do you find the area under a curve. So let's say we have a function called f of x here, and this is the line that represents it. And we want to find the area under the curve from a to b. And how would we exactly do that? We will take the integration of a to b. The higher limit is up, the lower limit is down, and we simply integrate the function, right? Now, in improper integrals, we have two cases. So the first case, let me draw the graph because it's more easy to understand through the graph. We have a line, and let's call this 5, this point, and we want to find the area from 0 to 5 from here. And this line keeps going until 0. So we don't know exactly when does it stop. So this is when we have infinite range, and the integration for this will be from 0 to 1 integration, we write it over here, to 5 of the function. And the other case that we can have is infinite domain. So let me draw a smaller graph over here. It's going to be from here, and this is line is continuing until infinity. So the area is from, let's say, 1 to all the way to infinity. So it's going to be integration from 1 to infinity of this function. So these are the two cases that we can have in improper integrals, and this is called infinite domain. Now, even for the answer, we can have either to infinity, the answer could be infinity, or it could be a number. So as you can see in this graph, we have a line which is going to infinity, and the area keeps increasing. So let's call this f of x dx, and the answer for this is infinity, and this is a diverging integral. Now on the other hand, let's draw another graph over here, and let's call this, let's call this 1. And here we notice that the integration, so if we take the integration from 0, from a to infinity, we notice that the line is approaching the x-axis, right? So as it gets very close to the x-axis, this area will be negligible, right? So somehow we need to find the integration of f of x, and this will be a finite number, not infinity, and this is called a converging integral. And the way to think about this converging integral is, let's say we have 1 plus 0.1 plus 0.01 plus 0.001 and so on, and this continues until infinity. Now what do you think the answer for this will be? Will it be infinity? It will be a finite number, since as we get a smaller and smaller number, they are insignificant or negligible compared to the digits that we have over here. And that's the logic behind this converging integral. So as we get closer to x-axis over here, the line keeps getting closer. It will never be 0, but it will be so close to 0 that it is negligible. So that is the logic behind these two integrals. Now let's start with our questions. So let's say we have the integration of 1 to infinity ln x over x squared dx. Now the first step is to get rid of this infinity. Since infinity is not a number, we need to use limits over here and replace infinity with a variable. So let's call b is approaching infinity, the same integration from 1 to b, and ln x over x squared. This stays the same. So all we did over here is replace infinity, since we cannot have infinity in the integration, and we need to replace it with a limit that b approaches infinity. So now this next step is to just integrate this part, the equation, and then we will place the limits inside. So now the way to integrate this is, we notice that we cannot use u substitution, so we need to integrate by parts. So we need to choose u here and dv. So u here is going to be ln x, dv is going to be 1 over x squared dx, and du is going to be 1 over x dx, and d is going to be, integrate this side now, so integrate 1 over x squared. It is going to give us x minus 1 over minus 1, and we can replace this with minus 1 over x. Now the formula was uv minus the integration of v du. So we have u, we have v, and wait a second, yeah, this is v, sorry, and we have du over here. So now we just place the variables over here. So it is integration. I'm going to leave the limits for now and just integrate this part. So ln x over x squared dx is equal to u v, so it's going to be minus ln x over x plus the integration of, or u minus minus is plus here, the integration of v, which is 1 over minus 1 over x, but I took the minus out, that's why it became plus, since we have a minus in the formula also. And then it's just going to be 1 over x du now. Du is also 1 over x, so it's going to be 1 over x squared dx. Now simplifying this and finding the integration of this part over here is going to be minus 1 ln x over x minus 1 over x. And now we need to bring back the limits. That's the only one thing that's left now. So it's going to be from b, which is infinity, to 1. So now let's substitute those two values. So here we have, I'm going to substitute b first, since it's the upper limit, ln, I'm going to open brackets also, or you know what, I'll use the square brackets, minus ln b over b minus 1 over b minus, now I'm going to substitute 1, so it is minus ln 1 over 1 minus 1 over 1, close brackets. Now we know that ln 1 is 0, so we can just equate this to 0. So now all that's left here, if I simplify, is going to be equal to minus ln b over b minus 1 over b. This is 0, so it's just going to be plus 1, since this minus is going to be distributed over here, and that is also 1. So now all that's left here is to take the limit from b approaching infinity. So now let's write that down. So limit b is approaching infinity of minus ln b over b minus 1 over b plus 1. Now we can separate this and take limit for each of them separately. It will help us. So it's going to be limit from minus ln b over b minus the limit b approaching 0, infinity, of 1 over b, and the last one is just a constant, so I'm going to leave it as is. So now we know that 1 over infinity is not equal to, it's approximately or equal to 0, since a number divided by infinity is going to be very small. It's going to be negligible, right? It's going to be 0.100 zeros or infinity zeros and then 1. So we can say that this part over here is 0. So I'm going to erase it, and it's all that's left is plus 1 here. Now we are left over with this one, this limit. So now all that's left here is minus ln b over b. Now if we substitute b with infinity over here, what will we get? Ln infinity is infinity, right? So I'm going to write infinity, and b over b is also infinity. So now whenever we have infinity over infinity, or let's say 0 over 0, we need to use L'Hopital rule. I don't know if I'm spelling it right. So whenever we have infinity over infinity, or 0 over 0, or minus infinity over infinity, or something like that, we need to use L'Hopital rule. And that is simply that we take the limits and we derive the numerator and the denominator. So here, if we find the derivative of minus ln b is going to be minus 1 over b, over the derivative of b here is just 1. And if we now find the limit from b approaching 0, we will get this is 0, since a number divided by infinity is 0. So we will be left over with 0 over 1, meaning that this is equal to 0. So now we can conclude that this limit is also 0. So now all that's left here is 0 plus 1, and the final answer is 1, is equal to 1. So now let's move on to a similar question, question 2, of 1 to infinity ln x over x. So in our last example it was ln x over x squared, and now we're doing ln x over x dx. So this time we first of course replace the limits with a b, infinity with a b. So b approaching infinity, and 1 to b ln x over x dx. And here we don't need to use the integration of parts by parts, we can use u substitution. So let's call u to be ln x, du is going to be 1 over x dx, and that makes, so dx is equal to x into du. So here we can replace dx with our du. I'm going to leave the limits now and just integrate it normally. So ln x is u, and x is going to cancel out with this du. So all we'll be left with is du over here. And I can do that workings also. So we can replace dx with x du, and you can see that the x's cancel out and all we'll be left with is du. So now just integrate this. So it's gonna give us u squared over 2, which is ln x squared over 2. So now we need to place the limits, and I'm going to take the squared outside. So now this is equal to, let me place the limits, so b and 1 over here, and this is equal to ln b squared over 2 minus ln 1 squared over 2. And as ln 1 is 0, so we can cancel this thing right here, and all we are now left with is ln b squared over 2. So now let's write the final thing. We limit b approaching infinity of the whatever left over is here, so it's going to be ln b squared over 2. And we know that ln infinity is infinity, right? Ln infinity is going to be infinity over 2. That does not make a difference, it's still going to be infinity. So the answer over here is infinity. That's it. And since this is infinity over a constant, this is still going to give you infinity. Now if it was infinity over infinity, then you need to use the same method as before, L'Hopital rule from before. But here it's pretty simple and straightforward. So it was ln b squared and b approaching 0, so, and we know that ln infinity is also infinity, so this is going to give you infinity, and this is called a diverging integral. Let's move on to a more complex example. So here we have from negative infinity to positive infinity 1 over 1 plus x squared dx. Now you might notice that we have two infinities in our limits. So here we need to choose a middle point. Let's call it 0 because that's the easiest one. So first I'm going to do negative infinity to 0 of the same integral, so 1 over 1 plus x squared, plus from 0 to infinity the same thing. And this is very important to do because we cannot do, like, let's say a is negative infinity, limit a approaching negative infinity, and then also b approaching positive infinity, and we take the integral from a to b. We need to always divide it if we have two infinities in our limits. And we can choose the middle point to be anything. I just chose 0 since it's the easiest. So now you can write the limits also. Let me write it with the limits. So here is the integrals with the limits, and now I'm going to divide these two integrals in two parts, and I'm going to integrate them separately. So this is going to be case 1, and this integral or the limit is going to be case 2. So now what is the integration of 1 over 1 plus x squared? This is arc sine or inverse sine, not sine, sorry, tan x, and we take the limit from 0 or 1 to 0, a to 0, where a is negative infinity. And for 2, it's gonna be arc tan of x from 0 to b, where b is positive infinity. So let's place the limits for the first one. So they're going to be equal to arc tan of 0 minus arc tan of a, and we know that arc tan of 0 is 0, so I'm going to cancel this out. So here all we have left over is negative arc tan a, and we can take the limit now. So it's going to be limit arc tan of a approaching negative infinity. And you might have noticed that I just dropped the sign. We can switch the sign later onwards. That is not an issue. And now to be able to solve this limit, we need to go back to the graph of arctan. So the graph of arctan is pretty simple. Let's call this pi over 2, and this is negative pi over 2. Let's draw two lines over here, two dotted lines, and the line or the graph of arctan is approaching pi over 2 over here and approaching negative pi over 2, and it can never go higher than that. So that is approaching, this is x-axis, and it always approaches pi over 2, but it never goes above it. So the highest, or the range, the highest number, x number, that this can have, or the y number, sorry, the range is pi over 2, right? And if you also put any value for arctan of a, let's say a is like 999 or 9999, you will still get the same value, which is going to be pi over 2. Oh my bad, it is negative infinity. So here we need to look at this part. It's going to be negative pi over 2. And since we have a minus sign over here, we take that in count, and that will switch the sign. So actually it's better that I take minus arc sign limit of minus arc sign. So this is going to be positive pi over 2. So this entire first part is going to be simply pi over 2. And as I mentioned before, you can type on your calculator right now, open your calculator and just take negative tan inverse of this is negative infinity, so just minus or negative 999. You will get this 1.56 or 1.569 something, so that is pi over 2. And if you now let's say put 9999, you will get 1.57, and you know that is approaching pi over 2. So let's say I put a ridiculously large negative number over here, I'll get the same answer, which is 1.57. So we know that this part over here is going to be equal to pi over 2. So now let's move on to the next limits. Let me erase and make more space here. This was pi over 2, so I'm going to erase everything else. So this is going to be equal to arc tan of b minus arc tan of 0, which is 0. So I'm going to erase this with 0, is equal to arc tan of b, where b is approaching positive infinity, and as we mentioned before, this is going to be equal to limit of b approaching infinity, the same thing, is going to be equal to pi over 2, as we mentioned before. So the highest number or the highest y arc tan you can get is pi over 2 for positive infinity, and the lowest or the lowest y value arc tan can have is negative pi over 2. So now we just add these up. So pi over 2 plus pi over 2 is going to give you pi, and that will be the answer of this question. So now let's move on to a different type of improper integrals. So let's say we have integration of 0 to 1. We don't have any infinities in the limits, and we have 1 over 1 minus x dx. So the first issue that we can see here is that if we substitute here as x is 1, this will be equal to undefined. So we cannot have x is equal to 1, right? So here we need to take a limit for 1. So this is equal to limit b approaching 1 minus, this means that it is going to 0.9999 and so on, but never 1 basically. And 1 plus is 1.0000 and then 1. So many zeros over here, but never 1 itself. So that is the logic behind these 1 minus and 1 plus. From 0 to b now, we are replacing 1 with b. The same thing, 1 over 1 minus x. And now let's integrate this now. So let's take u as the denominator, which is going to be 1 minus x. Du is going to be minus 1 dx. And let's replace dx over here. So this, I'm going to take it down now, is equal to integration of, I'm not going to put the limits for now, minus 1 over u du, and we know that the integration of 1 over variable is minus ln u, and now we need to apply the limits. First let's substitute u as what we have before, so minus ln of 1 minus x, absolute values, from 0 to b. So now let's plug in the variables. So it's going to be minus ln 1 minus b, and please note that the lines are also absolute values, Okay, I'm gonna change it by this one, yeah. So now it's more obvious. Plus, this is gonna be plus because there's two minuses here. Ln 1 minus 0. And we know that ln 1 is 0, so we can erase this entire thing. And now all that we're left with is minus ln 1 minus b, and b approaches 0. I mean not 0. B approaches 1 minus. So now let's ignore the minus sign for now and just look at what we have over here. So we have ln 1 minus b absolute value, right? And we know that b is approaching something like 0.99999. So what we can do here is we can substitute this on our calculator. So we will get something like 0. Ln 0.001 or even more zero. So you can try this out on your calculator right now. So let's try 0 ln 0.0001 and realize that we are getting I tried 0.001 first, so we got negative 6.9. So now let's add more zeros and try. So I added a lot of more zeros, and we realize that the more zeros that we are adding over here, the larger or the more negative the answer is getting. So we can conclude that this answer ln of 1 minus b is negative infinity. And now if we even draw the graph for ln, you will realize that so let me draw the graph. So we can see as x here approaches 0, the line is going to negative infinity, right? So here ln 1 minus b it's negative infinity, and we had a minus sign outside, so the answer would be positive infinity. So let me actually, is equal to minus minus infinity, and that is equal to infinity. So the answer of this question is simply infinity. So now let's do our last example, and the question is negative 1 to 1, and we have the integration of x to the power of 2 over 3 in the denominator. Now you might realize that the limits here don't make the denominator or the integral undefined, but here we are facing an even bigger issue. If we replace 0 here in the denominator, this will be undefined, and 0 is in the limits. So what here we are facing, if I draw the graph, it will be more clear. Let's say this is negative 1, this is 1, and the graph is something like this, where 0 here is a vertical asymptote. So that is the issue that we're facing, and here we need to split the integration from negative 1 to 0 minus, and from 0 plus to 1. So let me write it now. Limit b is approaching 0 minus, and it's going to be minus 1 to b first, same thing, dx over x over 2 over 3 plus the limit b is approaching 0 plus this time from let me change this to a to 1, and now we integrate this normally. So now let's find the integration of dx over x 2 over 3. So I'm going to bring it up. It's going to be minus x minus 2 over 3, and let's integrate this now. So it's going to be equal to x 1 over 3 over 1 over 3. So I'm going to bring the 3 up. Since it's over here, then I just brought it up. So now we find the limit from minus 1 to b. So let's do that. It's going to be 3b 1 over 3 over 1 minus 3 minus 1 1 over 3 over 1. And we can simplify this part over here. So negative 1 to the power of 1 over 3 is negative 1. So anything, 1 to the power of anything is still 1 or negative 1. So here we have minus 3 multiplied by negative 1. Yeah, that's it. It was over 1, but I just ignored that. And this is equal to plus 3. So now we are left over with the limit here. So I'm going to take the limit over here. Limit b is approaching 0 minus of 3b 1 over 3 over 1. So ignore that. And here we know that b is approaching 0. So it's simply b 3 multiplied by 0, which is 0, right? And we can try this on the calculator. So just substitute b as something like 0.00 and add a lot of zeros. It's going to be minus, by the way, since we are on the negative side. Negative 0.00, let's add like 10 zeros and then 1. And to the power of 1 over 3, that's still the same. Or actually, that's going to make it even more smaller with the 1 over 3 exponent over here. And that is approaching 0. So it's going to be 3 multiplied by 0, which is 0. So this part over here actually is simply 3. And we found the integration before, so all we need to do here is just replace the limits this time. It's the same integration, by the way. A1. So now do the same thing again. It's going to be 3 1 to the power of 1 over 3 over 1 minus 3 a 1 over 3 over 1, and we know that this part is going to be 3 over here. And let's take the limit of a is approaching 0 plus of 3 into a 1 over 3. So here we are approaching 0 plus, and 0 plus, we can try some numbers on our calculator again. So it will be 0 point, add couple of zeros, like 10 zeros, and then 1. And to the power of 1 over 3, this is even going to make the number more smaller. So this is approaching 0. And 3 multiplied by 0 is also 0. So here we can conclude that this limit and integration is also 3, since we have a 3 over here. So the final answer would be 6. So as always, I do have a shortcut method for you guys as usual. So for this question, we had two integrations, right? So from minus 1 to first it was 0 minus, and then the other one was 0 plus to 1, right? So the first step is to find the integration of this on the calculator. So of course you should have the integration sign and the function. And all you need to do is type on your calculator the equation and find the limit from minus 1 to, let's say, first minus 0.001, and this would give you the some answer. Like, let me just try it on my calculator right now and tell you the exact value. And especially for limits, when you're approaching 0, the calculator is going to take some time. Just warning you guys in advance. And let's see what answer we get here. We got 2.7 exactly. So now what you need to do is increase it by a 0, one more 0, and find now with 3 zeros. So you guys are seeing what we are trying to accomplish here. We are seeing what the integration or what the integral is giving when it is approaching 0 minus 0 or 0 minus, which is this sign. So let's try with one more 0 here. And again, the more zeros you add, the more time the calculator is going to take. So start with a few more zeros at the start and then slowly, gradually increase it. So let's see how long this takes now. It normally takes a few minutes, by the way, so you don't need to worry about it that much. So we got the answer of 2.8607. So now we can again increase it by one more zero. And we see the pattern here. We are approaching 3, by the way. So let me just try it with one more zero. So adding one more zero is giving me the answer of 2.93 something. So you guys can see that we are getting the answer of 3, and this will work the same for the other limit, which is from 0 plus to 1. So now I added 10 zeros and then 1. So let's see how long it takes for the answer. It's gonna give you something like 2.99, very close to 3. So it took exactly 1 minute, I think. So it's not that long of a time. But yeah, we got the answer of 2.9986. So this is extremely close to 3. And you can conclude or guess that the answer is 3, right? It's pretty obvious. So you should add more zeros, like 10 zeros or 11 zeros, and then see what the answer is also. And this also works for the infinities, by the way. So let me take an example for that. Actually, leave that one. Okay, yeah, so this one. We had the answer of infinity, right? Yeah. So here we have from 1 to infinity, then x over x, right? So here what we need to do is start by a smaller number, not infinity. So let's take 1 to 999 and the integration, and this will give you the answer of 23.85 instantly in few seconds. Now again increase it by one more 9. So let's take 9999 now and see if the number is increasing exponentially or not. This is the main trick in this type of questions. So let's try that now. And in few seconds now it should give the answer. We didn't try that big of a number till now. And of course, the larger number you will try, the larger number you will get. So now we got 42.41. So we can see that the answer is increasing. So now let's try a more huge number. So let's try with 10 nines. So 999999999, and see what answer do we get. So if this was an MCQ question, you would solve it instantly with the calculator. You don't need to do any calculation or any type of stuff. Just directly try all the options, or do this on the calculator, and you'll get positive infinity, and you can directly conclude the answer. So now we got the answer of 169.66. So we know that the integral is increasing exponentially. So we can conclude here that the answer is positive infinity, which is the answer. Since we are not going to a number like before 2.999, we were going very close to 3, but here we are increasing, so it must be positive infinity. So if you have any questions about this in the comment section, I'll be more than happy to answer, and I will be making a short video on how to do this on the calculator, of course. And thanks for watching.